Welcome back. In today's first lesson of this new unit, we're going to introduce the idea of inequalities. In the last unit, we had two things that were equal to each other and we had to solve, and we got one answer, sometimes no answer. In this unit, we're going to talk about answers that could have a variety of solutions. So today you're going to be able to solve linear inequalities like we've been solving equations with one little extra twist, and you're going to be able to graph that solution on a number line. So this should all be pretty much review today, but I want to get some definitions down so you have them in your notes for later. So an inequality, what does an inequality actually say? An inequality says how two values are related to each other. There are symbols that show in what way they're related. Okay, so here are the four symbols that you've seen in the past. The first one is our less than sign. So that symbol with the arrow pointing to the left, and that's sort of the word association I think of it. This is a less than sign, points to the left. When you see this graphed, it's either going to have an open circle and an arrow pointing that way, or the new thing we're going to talk about is a parentheses opened that way to the left. So that's the way that looks when you graph it. The next symbol is our less than or equal to sign. And that means that the number is less than the other number, or it could also be the same as the other number. So less than or equal to. This is going to be a closed circle because of the equal to part. It's got that line underneath, and it also points to the left because it's less than. We're also going to learn this new notation with a bracket and then an arrow pointing to the left. So those are both the ways that we can graph that symbol. The next two are our greater than. So the first one is the greater than without the equal to. So that's just our greater than symbol. When we graph that, we can have an open circle, and then now the arrow is pointed to the right. We can also have a parentheses and an arrow pointed to the right when we graph. Okay. And the last one is our greater than or equal to. Okay, and that's going to look like either a closed circle with an arrow pointing to the right, or it's going to be a bracket with an arrow pointing to the right. Those are all four of our different symbols that describe how two numbers can be related to each other. Less than or equal to, greater than or equal to. So what I'm going to want you to be able to do is I'm going to want you to be able to look at an inequality with a variable and graph that inequality on a number line. So let's look at example A. A says x is less than 4. That's how you read that. And so I'm going to put that even in quotes here as our first example. X is less than 4. So we can graph this two ways. The first way is we can, and I'll do this in a different color, is I can say that I've got an open circle on 4. Okay, and then my arrow points to the left on the number line. I can also, above the number line, make a set of parentheses and draw my arrow to the left as well. Either of those two ways are good for me. I really, really would like you guys to focus on the one above the number line and not the open and closed circles, but you're going to see it represented in multiple ways, so it's important to know both. Open circle is the same as a parentheses. In fact, I'll even make this parentheses a little bit more round, so you can kind of tell the difference between that and the arrow. Okay. All right, letter B says x is less than or equal to -1. So I'm going to go to -1, and I can either draw a circle here, And now my arrow is going to point to the left because it's less than or equal to. Or I can make a bracket and point left, less than or equal to. Okay. For C, x is greater than -5. I'm going to make a parentheses at -5. And now that this is greater than, I'm going to point my arrow to the right. Notice that your arrow here, see how that points to the right? Also points to the right here when you graph it. They both point the same direction. And letter D, I have x is greater than or equal to 0. So I'm going to make a bracket pointing to the right because it's greater than, and make my arrow to the right. So that's how you graph what these statements are saying. What this means is, more importantly, is that, like, for example, D here, this means that x can be any number greater than 0. So it's saying that any of these numbers here, 0 included, could be an answer to my statement. I could say 1 is greater than 0, 2 is greater than 0, 3 is greater than 0, etc., and it all makes sense. Okay. Let's reverse that. What happens if I give you the graph? Can you come up with inequality it matches? So the first thing I always do with these is I always start off with my x. Oops, not with that marker though. Let's try that again. So I would start off with my x and then ask myself, what does this symbol mean? This bracket pointing to the right is a greater than or equal to symbol. Okay, it's the bracket means it's equal to, and the arrow pointing to the right means it's greater than, and the number it's on is -5. So x is greater than or equal to -5. Example B, again, I'm going to start with my x. This is going to the left, so it's a less than, and it's a bracket, so it's also an equal to, and it's on the number 3. Letter C, always start with my x. It's going to be a greater than symbol because it's pointing to the right. It's not going to have an equal to because it's a parentheses and it's on the number -2. So x is greater than -2. And finally, letter D, I start off with my x. This is going to be a less than symbol, not an equal to because it doesn't have the bracket, and it's at the number 1. So being able to graph these and then being able to write them from the graph is a skill that you're going to have in this target. The last thing we're going to do is going to be able to solve linear inequalities, which is solving it's very similar to solving a regular equation we've been doing all last unit, except this time we have one really important rule that hopefully you recognize and remember. When you are solving a linear inequality that has an inequality symbol instead of an equal sign, you must always flip the symbol, flip the inequality symbol, when you multiply or divide by a negative number. A negative value. Okay, so let's take a look at some examples and see when that comes up naturally. So example A, I've got x minus 6 over 4 is greater than or equal to 1. I would still draw your line down the middle. That doesn't change from the last learning target when we're solving. Draw your line down the middle of the symbol. Okay, to get rid of this 4 in the denominator, like we learned before in 2.5, we're going to multiply both sides by 4 to get rid of that denominator. The numerator stays x minus 6, bring down the greater than or equal to. These cancel out, and 4 times 1 is 4. My next step is then to add the 6 on both sides. The 6's cancel. I bring down my greater than or equal to sign, carry it down, and I get x is greater than or equal to 10. When I graph this now, because I'm going to want you to be able to solve it and graph it, I'm going to go ahead and make a bracket on the number 10 and an arrow pointing to the right. Okay. Letter B. I did letter A because I want you guys to remember how to get rid of a denominator in an inequality or an equation. That's really important, so I thought that'd be a little bit of review. For example B, let's draw our line down the middle again. And now the first step we have to do is distribute just like we would do in a previous equation. Bring down that greater than symbol and bring down the right side. On the left side, I'm going to have negative 6x plus 2. Now I can start adding and subtracting my variables and my values. I like my variables on the left, so I'm going to get rid of that plus 3x on the right. These cancel out, and I end up getting negative 3x plus 2, because I'm going to bring the 2 down, bring that 17 down. Then I'm going to subtract the 2 on both sides. I get negative 3x greater than 15. And then here's the trick. When I divide by this negative 3, that negative right there on the bottom, that negative and that negative means that I have to then flip my sign. So I'm going to have a less than symbol now instead of a greater than symbol. The same rules apply though. These cancel and I get x is now less than or equal to negative 5 as my answer instead of greater than. It flipped the sign. So I'm going to go ahead and put my parentheses on negative 5 and an arrow going to the left. So in this particular problem, not only do you need your solving skills from the last unit, but now you need this idea of flipping the symbol when you get to a negative. Okay. Let's do 2 more examples that highlight a couple interesting things. So example, I lettered these. This should be A, B, C, and D. Okay, so on your paper, we can write that this is example C, and this is example D. Not a big deal. Okay, so on letter C, I'm going to go ahead and draw my line down the middle. I'm going to distribute this 8 to either thing. I'm going to bring the 5 down. We're not ready to deal with him yet. 8 times 5 is 40. 8 times x is 8x. Less than or equal to 36 minus x. Now, one of the tricks here is recognizing that this actually has an invisible 1 in front of it. That x is negative 1x. So when I go to get the x on either side, I'm going to go ahead and add it over. So I'm going to add the 1x to both sides. The other thing I can do is I can combine this 40 and this 5 together to make that 45. 8 plus 1 is 9, so I get 45 plus 9x. Bring down the greater than or equal to, and that's going to be 36, because I'm bringing that down as well. Let's subtract the 45 to start getting that x value alone. Bring down that symbol. I get 9x is less than or equal to negative 9. When I divide, be very careful here. I see this mistake a lot, is that we are dividing by 9, but oftentimes students see this negative here in front of the 9 on the numerator. We do not flip when that happens on top. We don't flip. We only flip when the negative is in the bottom. So these 9s cancel, and I keep it as a less than or equal to, and that becomes negative 1. So that's a mistake I see often is, do I flip when it's negative on top? Nope, you only flip when the negative is on the bottom in the denominator. So this is going to become a bracket going to the left. You could also do these with a closed circle on the number line going to the left as well. Okay. And then finally, for letter D, this one's a little bit more complicated, a little bit more time consuming, and that's okay. We've just got some more numbers to deal with. Okay, so I'm going to draw my line down the middle. I'm going to distribute both sets of parentheses. So I get negative 10 plus 10x plus 1 is less than 30x plus 42 minus 3x. Now I do have some like terms. On the left side, I have this 1 and this negative 10. And on the right side, I have this 30x and this negative 3x. So I'm going to need to combine those together. So on the left side, I'm going to have 10x minus 9 is less than 27x plus 42 when I simplified and combine like terms. Now I'm going to go ahead and subtract the 27x over. These cancel on the right, and I'm going to have negative 17x minus 9 less than 42. Add the 9 to both sides, and I'm going to have negative 17x less than 51. Now, when I divide by that negative 17, what do I have to remember to do? Flip the sign so it becomes x is greater than negative 3. And I'll even highlight that to remind you, hey, there's a negative in the bottom. That means I need to flip. Do that again. Flip. So when I go to graph this, I have x is greater than negative 3, so I can put a parentheses on negative 3, draw my arrow. I could also put an open circle on negative 3 and draw my arrow to the right. Either way means the same thing. Okay, so that's solving inequalities and be able to graph inequalities. Good luck on your practice, and as always, ask me if you need help.